Today's lesson is about properties of special parallelograms. Our special parallelogram shapes are rectangle, rhombus, and square. I'd like you to take some time to go on to either GeoGebra or Geometry Pad that we were using yesterday, and I want you to bring up a rectangle. Check out the diagonals specifically on the rectangle. Are the diagonals congruent? Write down the things that you need to explore. Are they congruent? Do they bisect each other? Do they bisect the angles at the corner of the rectangle? Are the diagonals perpendicular? Write down your answer on each of those as you're exploring on Geometry Pad. Then have it create a rhombus for you. Put in the diagonals. Do the same thing. Check to see, are the diagonals congruent? Do they bisect each other? Do they bisect the corners of the rhombus? And are they perpendicular? And then finally do the same thing with the square shape. Go through those same 4 questions. I'd like you to take about 10 minutes to go through each of those shapes, checking out the diagonals, the angles, and so forth before you would move on. So escape out of this, go into Geometry Pad for a while, and then come back. Right, your definitions now after your explorations. Rectangle is a special parallelogram. It's defined as just a quadrilateral with 4 right angles. So just any 4-sided figure that has 4 right angles is a rectangle. Some of the properties you should have found as you explored. The diagonals are congruent on a rectangle. They're not perpendicular. You should have found they do bisect each other. Well, that falls under the category of parallelogram. So that kind of supports our theorem 641. If a quadrilateral is a rectangle, then it is a parallelogram, meaning that anything that's true about a parallelogram is true about a rectangle, because a rectangle is a parallelogram. That could be supported by just the right angles that come from the definition, because notice that hypothesis picture of the rectangle. We have opposite angles congruent, both pair, which was one way to determine that you have a parallelogram. Another one was if you have one angle that's supplementary to both its consecutive angles, that creates a parallelogram. So there are more than one way you could support the conclusion on theorem 641. On 642, if you have just a parallelogram, I guess it says that is a rectangle. So you have a rectangle, the diagonals are congruent. So anything that's true about a parallelogram applies to a rectangle, because basically a rectangle is a special parallelogram. Let's apply that theorem, or those theorems. Okay, woodworker constructs a rectangular picture frame, and it gives you a measurement of JK and JL. Find HM. As you go through this, pause so that you can work the problem, and then start me back up so that you can see what the result was and the reasoning. So in this one, diagonals are congruent in a rectangle. So KM is 86, JL is also 86. The diagonals bisect each other. That's because a rectangle is a parallelogram, and in a parallelogram the other day we clarified diagonals bisect each other. So half of 86, HM would be 43. Same picture, a little bit different information, find KM. So give some thought, pause this presentation. Okay, how do you find Km on this one? Use the Pythagorean theorem. Well, where's your right triangle? Remember the angles on a rectangle are 90 degrees. So if I mark in this 90-degree angle, I'm going to concentrate on the triangle that is JLM. JK was 21, so LM is 21. Opposite sides of a parallelogram are congruent. KL was 72, and JM is 72. Maybe I should have highlighted triangle KJL. It would be the same idea. So then do Pythagorean theorem. Find the length of JL. You could put an X in there if you wanted to. JL is 75. KM then is 75 because in a rectangle, diagonals are congruent. Okay, on to a rhombus. A rhombus is another special quadrilateral. It has 4 sides and 4 congruent sides. So hopefully you explored the diagonals of the rhombus. Should find out the diagonals are not the same length. The diagonal that goes from the acute angle to the acute angle, like in this picture AC, that is longer than the diagonal going from B to D. And as the rhombus gets more squished, it becomes more and more obvious that they're different lengths. They do bisect each other because a rhombus is a parallelogram. One trait for a parallelogram was that if both pair of opposite sides are congruent, then it's a parallelogram. We definitely have that when all sides are congruent. The opposite ones are congruent. So the first theorem here, that if the quadrilateral is a rhombus, then it's a parallelogram, could be supported by both pair of opposite sides being congruent, creates a parallelogram. 644, if the parallelogram's a rhombus, then its diagonals are perpendicular. So the two diagonals meet at a right angle. We're going to be doing something with coordinates, so remember that if the slopes calculate to be opposite signs and reciprocals, that indicates that we have perpendicular lines. And 643, if it's a rhombus, then each diagonal bisects a pair of opposite angles. So what that means is if I look at diagonal BD, it bisects the opposite angles. So angle B is bisected. So angle 1 and 2 are congruent, and angle D is bisected. So angles 5 and 6 are congruent. The same with the other diagonal. Diagonal AC bisects angle A and bisects angle C. Now, if you give some continued thought to that, opposite angles in any parallelogram are congruent. So angle B's total is the same as angle D's total. So when you divide or bisect angle B and angle D, can you see that angles 1, 2, 5, and 6 would all be congruent? And another thing that would support that is angles 1 and 5 are alternate interior angles. So they are going to be congruent because the sides are parallel. It's a type of parallelogram. Angles 2 and 6 would also be alternate interior angles that are congruent. So we can support 1, 2, 5, and 6 all the same in more than one way. The same thing would happen with angles 3, 4, 7, and 8. So as I mentioned, rhombuses are special parallelograms, so everything that's true about a parallelogram is true about a rhombus. Let's try some actual calculation problems. And again, pause this after I've presented the problem so you have some time to think through it and work the problem like you were showing me your marker board. So how do you find the length of CD? Well, it's a rhombus, so that means CD is the same length as CG or FG. All sides are congruent in a rhombus. So set 5a and 3a plus 17 equal to each other. Solve. And then substitute back in. Where do you substitute into? Either CG or FG. They'll both calculate the same. And then your CD would be the very same length. Again, a rhombus, all sides are congruent. Okay, next diagram, find measure of angle VTZ, this angle. So now think through, what do we know about angles in the rhombus? You might have said they bisect. So 5a minus 5, the one I'm looking for would also be 5a minus 5. But we kind of get stuck there. Can't set those equal to each other because they just cancel out. So think some more about angles. Notice there's another angle given in this diagram. Diagonals on a rhombus are perpendicular. So that's a 90-degree angle. So how do we find A? We can put 14a plus 20 equal to 90 and solve. Then substitute in, and the angle VTX is 20 degrees, and so VTZ would also be 20 degrees. The diagonal bisects the angle of the rhombus. Okay, next one. So again, pause me so that you can do some thinking and figure it out on your own. I think I'm going a little bit fast. Let's back up. Okay, so on this one, we had the consecutive angles are supplementary. So angle GCH, excuse me, GCD. I had to read that again. GCD and then CDF. Ignore the diagonals for a little bit. Notice those are consecutive angles, so those had to add up to 180 degrees. That helped me find B. Now I'm going to take B and figure out what my missing angle is. The diagonal bisects the opposite angles. So if you substituted in and found this whole angle is 34 degrees, then the one that you're really looking for is half of that. So half of 34 was 17 degrees. All right, then a square is the last shape. 4 sides, 4 right angles, 4 congruent sides. If you look back at your definitions, you'll notice that the square is a combination of a rectangle and a rhombus. It's also a parallelogram because those original, the rectangle and rhombus are parallelograms. The square is going to be a parallelogram. So everything that applies to those shapes applies to a square. So a square has a lot of properties to it. We're going to show some of those properties by calculations. So show that the diagonals are congruent, perpendicular, bisecting each other. So there's 3 things you need to show on each of these. You're going to use calculations. So what will help you show diagonals congruent? What formula can we calculate? That would be the distance formula. To show they're perpendicular. Perpendicular we can determine using slope. So you'll find the slope of the diagonals. You want them to be opposite sign reciprocals. And then the bisector. Now there's different ways to do that. You could find how long and cut them in half, but actually kind of a neat way is if we find the midpoint of each diagonal, find where each one's bisected. If each diagonal has the same midpoint, that would show that that common intersection point is where they bisect. So let's go through the steps. The diagonals are congruent. If you didn't get those points written down, back up a little bit. Why don't I flip back one? Write down those points. Okay, so here's where I calculated the length. Notice I didn't even simplify the square root of 50. I just need to see if they're the same. Now to determine if they're perpendicular, calculate the slope of EG and FH. Make sure you're using the diagonals. You don't want the slopes of the sides. We already know that opposite ones are parallel. We're looking for the diagonals, whether they're perpendicular or not. They are in this case. They multiplied to be -1, which indicates they're opposite reciprocals. Bisecting each other, check out the midpoints. Midpoint of each diagonal. They are the same, so that would indicate they bisect each other. You know, if you had me do those calculations, you need to do them on this next example. So force yourself to stop this presentation, do the 3 different steps of calculating, and then double check with my presentation. Shut me off. Okay, turning it back on, here's to verify what you calculated. Okay, those are the steps. Okay, congruent should have come out with those numbers. Perpendicular, those were the slopes. They do multiply to be -1. Bisecting each other, they did have the same midpoint. So you're really just supporting the things about the square by doing calculations. Here's a proof for you to try. You were starting out knowing that PQTS is a rhombus. Now there are a lot of things you could pull up about a rhombus. Remember, it has all the features of a parallelogram plus some other things about its diagonals. Okay, and diagonal PT is in there. We want to prove RQ and RS congruent. So again, pause this presentation, then I'll show you the solution. You'll need this picture given and proof information to look back at as you see the solution. So think, if I'm given that's a rhombus, what all would I know? Try and get some triangles congruent, possibly. Here's a solution. Definition of a rhombus, all sides are congruent. So I got some triangles congruent by side, angle side, and then CPCTC supported the segments that I wanted. So look to see which triangles I got congruent. QPR and SPR. Maybe those weren't the ones you were thinking to get congruent. So here's a little check of understanding again. This is a rectangle shape. So pause and find each segment length. Here's a rhombus. Check to see if you understood a rhombus. Find a segment length and then find an angle. And finally, another one of those where you're calculating to show that the diagonals are congruent, perpendicular bisectors of each other in the square. Another chance to try a proof. Again, we started with a rhombus. You can get some segments and angles probably congruent based upon the definition of a rhombus or the fact that it's a parallelogram. And here are some of the ideas. I didn't put the theorem number for number 3 or 4. Perhaps you did. Okay, that's the end of the recorded presentation. You will have an assignment to work on. I'll see you the next day.